Alright, in this lesson we'll dive into the pandas date offset objects. And you could think of them as ways to modify existing times. So in all of the data frames that we've worked with so far, such as our Microsoft stock price, we've basically gotten our dates and we've stuck with them. We've extracted them, we've found out information about them, such as the day of the week they fall on, but we haven't really manipulated them. And by manipulate, I mean things like add days or subtract weeks, add months or subtract years. Find a way to bring that date to another date. So let's begin by actually running a new data reader method. Let's pull in a fresh set of data for us to work with, just so I can show you some of the available things that we can do with our data reader method. So I'm going to call data, which as you may remember is the module imported directly from Pandas data reader. I'm then going to place a dot and press tab. We can see that the data reader is our first option here. I'm going to select it, open my parentheses, and we can see our first four parameters are name, data source, start, and end. I'm going to put a new company for my name parameter. In the last couple lessons it was Microsoft. Let's now take a look at Google stock, and Google has the stock name or symbol of G-O-O-G, Goog. I'll place a comma here and move on to my data source parameter, and here I'm actually going to write Google. So we're going to be using Google Finance as our data source to pull in information about Google the company. Pretty cool. I'm going to place a comma here and actually a line break just so we can see what we're working with here. And then the next parameter in line is actually going to be, if I can go back actually, you can see it's start and end. So start, in the previous lesson we gave it a string, but just to show you that we can also give it another type of object. For example, we can give it a Python date. So if I do dt.date, and let's say I want to start at the beginning of 2000, I'll give the year 2001. I think Google went public sometime in 2004, so we should be able to capture all of its data. And for the end, I'm actually going to do something new. Instead of giving it either a string for a specific date or a date object or a date time object, I'm actually going to do dt, which is our library, then date time, which we're familiar with. But instead of doing anything here, I'm just going to write dot now and put a pair of parentheses at the end. So what this basically does is get the current time as a date time object in Python. So whatever day you're running in this code, it's going to get you up until that date. We're basically setting the end date to be a much more dynamic value. Whatever date we're going to be executing this notebook on, it's going to detect what that current date is with that datetime.now method and provide that as the argument to the data reader method, so we're always going to have the data up to date. That's one way that you can make it a lot more flexible in case you want to avoid doing things like manually writing in the end date each time you open the notebook, let's say on a different day, or if you check in once a month. This one allows it to be much more adaptable to future change. So let's take a look. I'll execute this and we'll get all of the Google stock information. You'll see these null values, these NaNs, populate in the volume column, and that just means the data is either missing or unknown. But you can see we have here Google's first public date, which is the 19th of August 2004. And if I scroll down, we'll see a gap in our data frame, and then we'll see all the way to the present day. So I'm recording this on the 17th of September, which is a Saturday. Here we can see we've gone up to the 16th of September, which is a Friday. Of course, if you're following along, that dt.datetime.now method will mean that your last row will be the current date, or at least the last day before the weekend. So that allows you to always have a much more modern data set, a more up-to-date data set. And here you can see we have 3,041 rows in my case, so we've basically pulled in all of Google's stock information over the course of 12 years within a second with a simple single method from our Pandas data reader library. Pretty impressive. So I'm going to store this again in a variable called stocks, and I'm going to preview it below with stocks.head. Let's see the first three rows, and there it is, and now we're ready to work with it. So as we know, our date time index is easily accessible through the index attribute. So when I execute that, I'm going to get the date time index with all of my dates in sequence, in order. And now what I want to do is show you this date offset object. So basically what it does is generate a amount of time, but that time doesn't correspond to something like a date. It's not so much a date as it is a length of time or a duration. And what we do with that is we tell pandas that we want to add that duration or subtract that duration from an existing time. So for example, let's say I want to take my current dates here and I want to add 5 days to each. Now if I just did something like +5, we'd get an error. And the reason is because it doesn't know how to apply something like an integer to values that are date time objects. So we have to try something different. So I'm still going to use the plus sign. That's basically the universal sign for addition, and we want to add time. But now I'm going to do PD dot, and I'm going to look for something called date offset. You can see it's this thing here, capital D, capital O, date offset. Let's select that. It is an object, or basically a constructor method that creates an object. So I will need parentheses at the end. Let's see if any of the documentation appears. So the documentation here can be a little bit misleading because it doesn't actually show you all of the available options. But the parameters here that you can enter are just going to be the types of values that you can add. So things like days, weeks, months, years, hours, minutes are all available parameters here. So let's show you an example. If I want to add 5 days to every value, every date time object within my index, I can write days equals 5. Now let's execute and see what happens. As we'll see here, our very first date in our original stocks data frame is the 19th of August. And now the very first date in our new date time index is the 24th of August. And you can see that it's added 5 days to my original one, as well as every other timestamp within my stock data frame index. So now I have a brand new date time index. If I wanted to overwrite my original data frame, I could just do something like this, and I would easily add 5 days to every value in my stocks index. Let's do another example. By itself, of course, this does not modify the original one, so we can continue playing around with it. So let's say I wanted to add weeks instead of days. I can do something like weeks. And let's say I want to add 2 weeks to every day, which is basically the same thing as adding 14 days. When I execute this, you'll see that we'll go from the 19th of August in our first row to the 2nd of September, which is exactly 2 weeks later, same day of the week. And in addition, we're not limited to just adding. We can subtract, and we subtract, of course, with our minus sign instead of the plus sign. So if I replace this plus with a minus, let's take a look at our dates. We're now going from the 19th of August. 2 weeks subtracted from that is the 5th of August. And the same thing will apply to every other timestamp within our date time index. As you may guess, we can also subtract or add things like months and years. So for example, if I replace this weeks with months, and I want to subtract 3 months, I just put months equals 3. So our parameter name is the time value, and the actual argument is the amount of that time value that we want to work with. And of course, the plus or minus specifies whether it's adding or subtracting. Here we're subtracting 3 months from every date. So we're going from August 19th to May 19th right here, all the way until the end of the data frame. You can see we're ending on the 16th of June, which is 3 months back from the last value in our data frame, which is the 16th of September. And similarly, we have something like years. So if I want to add a year, I would do years equals 1, change this to a plus. That's going to add a year. So we're going to move from the 19th of August 2004 to the 19th of August 2005. You may actually recall that I used the date offset in a few lessons ago. Whenever I wanted to generate that date time index of all of my birthdays, I basically used the year offset to pull every single occurrence of my birthday 1 year apart. The reason that we can't do something like adding 365 days or 52 weeks is because things like leap years can throw it off, and especially adding something like 30 days for a month can also get tricky because some months have 28 days like February, other months have 30, some have 31. Inside the pandas logic, writing something like months equals 1 is much more logical. It knows exactly where to add and how to get to the same place in the following month. So that kind of logic is built into it. We don't have to always think in manual terms. Let's try another example with hours. So right now our data frame index basically doesn't have time. It has dates, just straight dates, the 19th of August. Well, in this case, it's our modified one, but here we have the 19th of August 2004. So let's say I want to add 6 hours to each. I can do this. And you can see to make it work, it's going to add the time value to that timestamp. Originally, we just had the the regular timestamp with just the date, so basically a date instead of a date time, and behind the scenes that's basically registered as midnight. But now you can see we've added exactly 6 hours to every single date within our index in our data frame. And of course, so far we've been sticking to one parameter at a time. We've done days, weeks, months, years, hours, but we've all done them separately. However, you're certainly not limited. You can simply separate multiple parameters with a comma and make it happen. So for example, if I wanted to subtract, let's say I want to subtract 1 year, so I'm going to do years equals 1. I also want to subtract 3 months, months equals 3, and let's say I want to subtract another 10 days after that. I can just enter those 3 parameters separated by a comma in any order, and then execute that, and you'll see that it's going to subtract 1 year, 3 months, and 10 days from this value right here. So 1 year back from 2004 is 2003, 3 months back from the August is May, and 10 days back from 19th is the 9th. So we have May 9th, 2003, everything worked properly. And as I mentioned, if we simply reverse these arguments and put them in any order, it should be smart enough to figure out what we mean. You can see it's going to do the exact same operation. And if we want to add instead, let's add 8 months, 5 years, 12 days, 3 hours, and let's add a couple minutes. Let's add 42 minutes. You can see it's very quickly going to generate that new date time index. That's basically going to be all of those index date time objects are going to be modified to now have this new offset, this new addition of time or subtraction of time to be whatever we specify. And again, that's going to generate a brand new date time index. So if you want to reassign it to this data frame or maybe use it as the basis for the index in another data frame, it's just a simple matter of reassigning to that stocks.index attribute. So that's a quick introduction to the date offset object available in Pandas, which allows us to offset a date or basically move it from its original position to something else.